Hey, good morning, everyone. The previous lecture we started with the Fourier transforms. So, 2 to 3 examples we have already done, and now we want to go ahead. The next question is find the find Fourier cosine integral representation for the function f of x is equal to x square 0 for x greater than a. So we need to find out the Fourier cosine integral representation. For Fourier cosine integral representation is given by, first of all, it is denoted by f c of lambda, which is equal to integral 0 to infinity f of u cos of lambda u du. So this is equal to integral 0 to a u square cos lambda u du. As we have seen, this is a polynomial. So being a polynomial, we will use the generalized UV rule. In generalized UV rule, keep the first function as it is, u square. Integration of cos lambda u is sin lambda u by lambda minus derivative of u square, which is 2u. Integration of sin lambda u is minus cos lambda u by lambda square. Next derivative plus 2u का derivative is 2. Integration of minus cos lambda u is minus sin lambda u by lambda u 0 to a. Let's put the values. If you put the upper limit, we will have a square sin.
Sir,
Yes.
can you please accept the people? They are saying that they are in waiting room.
Look, they have to come on time. There's no necessity to disturb me again and again to accept them. They should
Oh,
come on time. I waited for a long time. Plus 2a cos lambda a by lambda square a by lambda cube. To put 0, all three terms are 0. So this is our answer. So this is equal to a square lambda square sine lambda a plus 2a lambda cos lambda a minus 2 sine lambda a divided by lambda cube. This is fc of lambda. Now giving the Fourier cosine integral representation, what we have to do is we just have to put this value fc of lambda in the inverse Fourier cosine transform formula. So f of x is equal to 2 by pi integral 0 to infinity e square lambda square sine lambda a plus 2a cos lambda a into lambda minus 2 sine lambda a divided by lambda cube into cos lambda x d lambda is our final answer. Next example, solve the integral equation solve the integral equation integration 0 to infinity f of x sin lambda x dx is equal to 1 minus lambda 0 less than or equal to lambda is less than or equal to 1 and it is equal to 0 for lambda greater than or equal to 1. So if you look at the left hand side, the left hand side looks like the Fourier sine transform of a function f of x. Solving this integral equation means that what we have to do is we need to find the function f of x such that the integral on the left hand side will become equal to the right hand side. So as I said, the left hand side looks like the Fourier sine transform. So if you take the inverse Fourier sine transform of the function on the right hand side, probably we will get the solution. This is fs of lambda, as you can see. So from fs of lambda, we need to find f of x. Solving integral equation means we have to find this. So what we do is f of x is equal to 2 by pi integral 0 to infinity fs of lambda sin lambda x d lambda. So this will be equal to 2 by pi integral 0 to 1 fs of lambda is 1 minus lambda sin lambda x d lambda. 2 by pi integration using generalized Riouvy rule 1 minus lambda as it is, integration of sin lambda x is minus cos lambda x divided by x minus derivative of 1 minus lambda minus 1 integration of minus cos lambda x by x minus sin lambda x by x square, limits from 0 to 1. Let's put the upper limit 1 minus 1, first term will be 0, in the second term we'll have minus sin x. So minus 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 triple minus, so minus sin x by x square minus, now you put 0, 1 minus 0 will be 1, cos 0 will become 1, that minus sign will make this plus 1 by x. So if we simplify this, what we have is x minus sin x divided by x square is 2 by pi. The solution of the given integral equation is this. So next example is very big, important, as it is different from all of the previous ones. Find inverse Fourier sine transform of fs of lambda is equal to 1 by lambda e to the power minus a lambda. So the inverse Fourier sine transform of the function fs of lambda will be given by f of x is equal to 2 by pi integral 0 to infinity 1 upon lambda e to the power minus a lambda into sin lambda x d lambda. A very important thing to note here is we have the formula for e to the power minus a lambda sin lambda x. So what do we do is we want to remove this 1 upon lambda.
सर कुछ बच्चे वेटिंग रूम में वेट कर रहे हैं उनको ज्वाइन
Look, you don't have to disturb me again and again. Someone is disturbing me again and again. If they are in the waiting room, they should come on time. In every lecture, I wait for minimum 5 minutes so that everyone can join. The ongoing lecture, you don't ask any difficulties and you disturb me just so that everyone can join. I'll call the integral I of x is equal to integral 0 to infinity 1 upon lambda sine lambda is k lambda. So differentiating with respect to x, so I dash of x will be equal to integral 0 to infinity 1 by lambda e to the power minus k lambda. Derivative of sine lambda x is cos lambda x into lambda k lambda. So this 2 will get cancelled out. Integral 0 to infinity e to the power minus a lambda cos lambda x d lambda. So the integration e to the power minus a lambda cos lambda x is a upon a square plus x square. So what do we have? I dash of x is equal to a upon a square plus x square. So I of x will be equal to integration a upon a square plus x square dx, which is tan inverse of x by a plus integrating constant c since it's indefinite integral. So what we have got is I of x is equal to tan inverse of x by a plus c. So I of x, we can observe this as I of x. If we put x is equal to 0, I of 0 is equal to tan inverse of 0 is 0 plus c. But if you see I of 0 is also 0, so sine lambda into 0 will become 0. So this gives me c is equal to 0. So we have got I of x is equal to tan inverse x by a. And so let's put it in the original integral. So f of x becomes 2 by pi tan inverse x by c. This is our final solution. If you want, and give you 2 minutes to write it down. Okay, so next question. Find the Fourier transform of f of x is equal to 1 minus x square mod x less than or equal to 1, and it is equal to 0 for mod x greater than 1, and hence evaluate integral 0 to infinity x cos x minus sin x divided by x cube cos x by 2 dx. Where is Yash?
Yes, sir.
Is this example done?
Uh, sir, what do you say? What
ये
did you
जो
say, sir?
एग्जाम्पल लिखा है ये हो गया है या बस आई मीन isn't done yet?
सर एक सेकंड चेक करता हूँ.
हाँ.
No, sir.
No, no. ठीक. So in this example, what we can observe is f of minus x is equal to 1 minus of minus x square. So which is 1 minus of x square is equal to f of x. So even if the question says find the Fourier transform, but what we observe is function is even, so I can quickly jump to finding out Fourier cosine transform. So f of x is even function, even. So find Fourier cosine transform. And so it is denoted by fc of lambda. Fc of lambda is equal to integral 0 to infinity f of u cos of lambda u du. Put the values. So integral 0 to 1. Since mod x less than 1 is, it actually means that minus 1 less than or equal to x is less than or equal to 1. So integration is from 0 to 1. 1 minus u square cos lambda u du. So this is equal to, let's integrate 1 minus u square. Integration of cos lambda u is sin lambda u by lambda minus derivative of 1 minus u square is minus 2u. Integration of sin lambda u is minus cos lambda u upon lambda square. Next is plus derivative of 2u minus 2u is minus 2. Integration of minus cos lambda u is minus sin So we have used the generalized UV rule to get the integral in one step. Now we put the upper limit. If you put 1, first term will become 0. The second term will be minus 2 cos lambda by lambda square. Third term will be plus 2 sin lambda by lambda cube. When you put 0, all three terms will be 0, as you can easily check. So this can also be written as 2 common inside bracket sin lambda minus lambda cos lambda total divided by lambda cube. So this is nothing but the Fourier cosine transform of the given function. Now what they are saying is to evaluate this. So if you compare this and this equation, what we observe is in this, I mean the equation that we have to find, in that if you replace x by lambda, you get this fc of lambda. So this sounds like Fourier cosine integral representation. Since there is one more term, it is cos x by 2. So what we will write down is Fourier cosine integral representation is so Fourier cosine integral representation is, so f of x will be equal to 2 by pi integral 0 to infinity fc of lambda, which is sin lambda minus lambda cos lambda divided by lambda cube cos lambda x d lambda. So that is the Fourier cosine integral representation. Now we have to simplify it in order to get the required expression. So I'll keep this expression as the left hand side, integral 0 to infinity. There is one more 2 there. So sin lambda minus lambda cos lambda by lambda cube cos lambda x d lambda is equal to pi by 4 f of x. Now we need to identify the value of x so that we get that required expression. So as what we can observe there is cos x by 2, and everywhere if you replace lambda by x, we get the upper equation. So what we will do is we will put x is equal to 1 by 2. So put x is equal to 1 by 2. So what do we get here is integral 0 to 1 infinity sin lambda minus lambda cos lambda by lambda cube When you put x is equal to half, this will become cos lambda by 2 d lambda, and the right hand side is pi by 4 f of half. But what is f of half? 1 minus 1 by 4. So from this expression, I am writing this 1 minus x square. So x is equal to half. So what we have got is 1 minus 1 by 4. So that will be 3 pi by 16. So now what we have to do is we have to replace lambda by x, and I have to take minus sign common, so that you will get this expression. So answer for this is minus 3 pi by 16. This is our final answer. Write it down. If you have any problem, you can ask.
Sir, why did we put x is equal to 1 by 2?
Yes, as you can see, eh, if you compare these two expressions, I mean the equation that you have to find out, this one, and if you compare this equation with this, what do we observe? At the place of lambda, it is x, right? An extra function, I mean variable in this is this. But if you compare these two terms, what do we observe? In one you have cos x by 2, and here you have lambda x. So in order to make them same, as I want the value of this expression, what I did is I did put x is equal to half, so that these two equations will, I mean, look identical. Am I clear?
Okay, sir.
Hmm. Okay, last question that you have to solve. Example, using Fourier integral representation, show that integral 0 to infinity cos lambda x plus lambda sin lambda x divided by 1 plus lambda square d lambda is equal to 0 for x less than 0, pi by 2 for x is equal to 0, and pi e to the power minus x for x greater than 0. Try this. Okay, any idea? Anyone? No idea. Okay, I'll just give you the idea how to solve it. So we have the given function f of x, which is 0 for x less than 0. It is pi by 2 for x is equal to 0, and pi e to the power minus x for x greater than 0. Okay. So if you find out Fourier transform of this, इसका Fourier transform find करना है. Find the Fourier transform. Fourier transform of this. Once you find the Fourier transform, give the Fourier integral representation. Fourier integral representation. Fourier integral representation, it will be this equation. Okay, so this is your process that you have to do, and this is also the end of the Fourier transform. In the next lecture, we will start with Laplace transform. Before I conclude, I'm creating a Google Classroom for your division. You all get added, and the 10:45 tutorial I will post it there, and you can start solving it. The previous tutorial one, which we conducted earlier, and I gave you 1 hour time, that will also be to be posted there. I will make sure that you are submitting it using hand in option. If not, it will be not considered for the assessment. Not be because I am rejecting it, but due to technical issues. So check out on YouTube how to use hand in option there, and submit it using hand in option, the previous one that we completed earlier. So today's tutorial I will post it at
Sir,
10:45. Yes.
sir, sir, hand in option means that only to that add attachment and mark as done work done.
Yes.
Okay, sir.
So today's will be a tutorial 2, right?
Yes. Today's will be tutorial 2. The tutorial 1 you have already done, right?
Yes, sir.
Yes,
Huh.
sir.
Yes, sir.
So submit it there. So fine then.
Okay, sir.
Mm,
Sir, which book can we refer for M3?
told you this HK Das, which is available on HK Das Higher Engineering Mathematics. It is available on Google. PDF format is there, and with that also this BS Grewal is also good book. BS Grewal application is available on Play Store. So you can search there BS Grewal and you will get an application which you can download. Everything is there. The books
Okay,
are
sir.
good. Yes.
Thank you, sir.
Mm.
Sir, and what is the midterm syllabus?
Is it declared for other subjects?
Uh,
Yes, sir.
yes,
Yes.
Uh,
kind of.
three of
Okay, I'll talk with the other faculties teaching civil engineering and I'll inform you. Okay.
Okay, sir.
Okay, sir.
Sriyash. Hello, Kavade.